Hi everyone, in this video we're going to be going through 2021 AMC 12B problem 13. It says, how many values of theta in the interval 0 to 2 pi satisfy 1 minus 3 sine theta plus 5 cosine 3 theta equals 0? So in this expression, what we're going to do is we're going to rearrange it. So we get 5 cosine 3 theta equals 3 sine theta minus 1. So we just moved this 1 minus 3 sine theta to the other side. And now what we want to do is graph our expressions. So most of you will know that the cosine graph looks something like this, where its peak is at 1 and its lowest point is at -1. So when you have 5 cosine theta, what happens is our peak becomes 5 and our lowest point becomes -5. So it looks something like this. So this is the graph of cosine theta, and this is the graph of 5 cosine theta. And then when you add some coefficient inside our cosine, it basically just squishes the graph together by that much. So previously in 2 pi, we would go through 1 cycle, and now in 2 pi, we're going to go through 3 cycles, since our graph got squished together. So that would look something like this. So it goes from 5 to -5, and it would just be squished together. Now we're going to do the same process as we did for this, and we know that the graph of sine theta looks something like this, with maximum of 1 and a minimum of -1. So when we have 3 sine theta, it's going to be just expanded up to 3 as its highest and -3 as its minimum. So something like that. That was pretty poorly drawn. And then when we have 3 sine theta minus 1, it's just going to shift our graph down by 1. So it's going to look something like this, where our peak is now 3 minus 1, 2, and our lowest point is -3 minus 1, which is -4. So now all we want to do is find at what points this graph and this graph intersect. So we're going to add in, I'm going to add in a nicer version of the graph so it's more clear. Now all we have to do is draw our sine graph. So it's going to look something like this. Its peak is going to be 2, and its lowest point is going to be -4. So it's going to look something like this, and now we just count solutions. It has one solution here, one here, one here, one here, one here, and one here. And as you can see, that's 1, 2, 3, 4, 5, 6 solutions. So our answer is just 6, which is D. So basically in this case, all we did was look at the graphs of 5 cosine 3 pi and 3 sine pi minus 1. And based on the initial coefficient is how much you expand it upwards, and this coefficient is how much you squish it on the x-axis. So based on that, we just graphed it and we counted the number of points of intersection and found that our answer was 6. Thanks for watching!